All right, everybody. So thank you for coming to my talk. It's called Visualizing Security. The subtitle of this is When AppSec Met LANGSEC. I know it sounds corny. It could probably be a CBS sitcom, but it is what it is. So a little bit about myself. I'll just cruise through this, and then we'll go right into the presentation. I started off my career working at a place right down the road from here, the Jet Propulsion Laboratory, NASA. And I got to work on all sorts of fun and interesting programming projects, whether it was business applications or science applications like the Mars rovers. And I got first-hand experience working with all sorts of novel languages like Safer C and Safer C++, and even helped contribute a little bit to those projects. So first foray into doing language analysis and language parsing. How can we design and build a safe programming language that other people could use? I then went over to a small social network that time has now forgotten called MySpace. You guys probably remember MySpace, especially from a security perspective, because of one gentleman in particular, Sammy, right? Exactly. And a little fun anecdote about Sammy. So I joined the company about maybe 4 or 5 months after the Sammy war happened. And when I showed up to MySpace, and you'll see it in this talk, it's a company that was using a lot of regular expressions to do a lot of HTML filtering, right? And I saw what Sammy's evasion, his technique was, and it was fascinating to me. And you'll see a little bit of that in this presentation, but years later, I finally met Sammy in person, and I was like, you were the guy that was trying to burn the house down, and I was the guy trying to save the house. And it was this really awesome experience of getting to talk to him and getting to hear his side, and also about how he thinks about LANGSEC and security in general. So very awesome to meet him again. Then I went over to the BBC. So the BBC is an interesting place. Basically a very large British organization, public service, the news, and worldwide has all the fun stuff. So if you watch shows like Doctor Who, Top Gear, Dancing with the Stars, I'll say Dancing with the Stars because it's probably the most successful BBC worldwide show ever. Basically, I worked on a lot of those brands, specifically managing technology and security as part of that. And then I started a company called Prody, so about a mile down the road from here in Santa Monica, doing application security. So today we're going to talk about LANGSEC. So I know it's an interesting term, you're starting to hear a little bit more about it, and there's a lot of great research that's coming out about it. And my goal today is to educate you a little bit about what LANGSEC is. We're going to actually walk through a Java implementation, and we're also going to do some fun data visualizations. I spent the weekend thinking about what would be impactful for this talk, and ended up developing a 3D data visualization using a tool called processing. And all the stuff that you see, code, slides, and even the data viz, all that's going to be online after the talk. And we're going to do a benchmark as well. We're going to also visualize the performance metrics. Basically, how does LANGSEC stack up and compare to alternative methodologies? And then we'll talk about different kinds of implementations and where we're starting to see LANGSEC being implemented today. So I'll just start off with some very, very basic information I think you guys already know. Saying a step already is just hard. It's very hard to do, especially when you're defending the castle. Sophistication of attackers has gone up, and it hasn't just gone up linearly, it's gone up exponentially. We're seeing all sorts of novel fuzzers. We see a lot of people using very interesting tools to test and validate that their vulnerabilities are in fact valid. We also see that the current approaches and current methodologies using things like signatures, whether you're using whitelists or blacklists, or you're using a heuristic-based approach using things like anomaly detection, they work, but sometimes they don't. And that's what's really interesting about this, because when you dive into something like signatures, you can see that they can take the form of whitelists and blacklists, and they can be literal strings, so if I want to block the word script, or if I want to block something based on a regular expression, when I see a script tag, or anything that kind of looks like a script tag, I want to block it. And I'll show you plenty of signatures and definitions as we go. I ended up pulling in this talk 50 interesting regular expressions, whether it was pulled out of some research that security researchers pulled out of Microsoft's DLLs, public DLLs, I guess. They pulled that stuff out. And then from the OWASP wiki with respect to non-security rules. So we'll see some stuff. And then the other interesting thing about signatures is that they're just generally hard to maintain. We have the fortunate privilege of getting to talk to a lot of CISOs and a lot of security teams at financial services and large organizations. And they always tell us that maintaining a list of regular expressions and signatures is really painful, especially as they end up going to different countries or working with different clients, having to take into account different regulations and managing those regulations with respect to signatures is really difficult. And also, we'll talk about in a second, what about performance and a potential for denial of service. Heuristics. So they can take the form of multi-criteria analysis. So basically security without looking at defining signatures in advance. So looking for things like abnormalities. So a really good example is abnormal behavior. How do you know if something is good or bad? Well, there's a logic, or there's folks out there that believe that you can define what's good or acceptable based on what you've already seen, what you've already processed before. And if you've never seen something before, that's theoretically good or bad. But it's up to you to still define the line and determine whether or not something abnormal is good or bad. And that can lead to false positives and false negatives in an environment. So as I said before, sometimes these approaches work, sometimes these approaches just don't. So story time, we're running the clock a little bit to MySpace. So I showed up at MySpace and it was basically Party City, right? They allowed people to put in whatever they wanted to in their profiles and very limited HTML validation. And the idea was around letting people communicate whatever they wanted. So you probably ended up going to profiles that had 20 or 30 YouTube videos because people were putting in, yeah, I've seen head nods. Everybody remembers the pain and frustration of going to a MySpace profile in 2006, 2007. They all were crazy. Flashing lights, blinking text, right? And fortunately, browsers got better. But the interesting thing about that was we allowed people to do whatever they wanted to, and the business wanted to empower our customers to do whatever they wanted to. But security was always an afterthought. So it wasn't until we started seeing lots and lots of attacks that we started to take security pretty seriously over there. But as I mentioned before, security was around regular expressions. So we had a regex that looked for the word alert. And every time it saw the word alert, we assumed that it was bad, and we would replace it with ... So I don't know if for those that ended up using MySpace in the mid-2000s, if you ever put in a piece of text that was on our blacklist, we did a literal string replacement, and we ended up replacing it with ... And the reason why we picked ... is with regular expressions, if you don't do it recursively, you can filter out the bad stuff, or what you think is the bad stuff, and the attack could come together because they're surrounding the actual payload that you're filtering out. And so we thought we could break the segmentation attack by inserting in a dead character or multiple dead characters like periods. But security will fuzz around this, right? You can turn that into that. It's the same exact thing. And this is from a tool called JJ Encoder. And I love seeing this stuff because JJ Encoder is just a fascinating tool. You can put in any piece of JavaScript and you get this lovely garbage out on the other side. It's still going to do exactly what you intended it for it to do. So we learned the hard way at MySpace, right? Because we ended up having a series of regular expressions, and when I say a series of regular expressions, not just one, not just 10, not just 100, we had about 1,000 regular expressions. Every piece of input, with every HTTP GET or POST request coming into the site. Think about that, 1,000. And when we internationalized the site, and we ended up going to different countries like China, well, the Chinese government gave us a series of regular expressions that we had to apply, which is ridiculous, right? And some very interesting terms on that blacklist. I know there's some fellow MySpacers here, and they remember the shenanigans of us looking through their blacklist and seeing things like Nepal in the blacklist. And we're like, oh no, what can we do? But we ended up learning the hard way because with all these regular expressions, we found ourselves wasting a lot of CPU cycles and burning quite a bit of CPU because people realized what we were doing, that it was just a bunch of regular expressions. So they started to post not just a little bit of content, but a wall of content. People started posting ebooks in their MySpace profiles, thinking that they could take us down because the amount of time spent by CPUs to process a payload was so significant that we could actually slow individual compute instances down. So we ended up having to throw more boxes in the VIP at night just so we could sustain traffic. So pretty insane. So when we think about different kinds of attack classification, and this kind of goes into LANGSEC, we think about static, we think about dynamic. Dynamic, we think about signatures, heuristics, and then there's language theoretic security, or LANGSEC. So this is the formal definition of LANGSEC, but I'll just speak very highly about it, and I'll start to unpack it in the subsequent slides, and it'll be a little more elucidated in the demos. So the general theory of LANGSEC is to understand what something is going to do, specifically a piece of content or a payload, before it goes to actually execute, and to do it via the same lens. So let's take something like database query. What if you could actually look at a database query the same way that the query planner inside the database engine would actually evaluate it? Because those things are anyways going to go and fetch information. What if you could do the same exact thing? So the idea of LANGSEC is to treat data formally as code and trying to examine things through the same way they would actually execute. And so it's formal data parsing. It's not ad hoc. It's not taking regular expressions or taking anything that can't work on a type 0 or a type 1 grammar, anything that is context-free, because those things don't necessarily apply to a non-context-free grammar. And to also reduce the number of tools. LANGSEC isn't about using a plethora of different tools that already exist today. LANGSEC is to really understand your language and bring the right tool that understands exactly what that language is going to do, or allow you to express behavior around that language. So I'll explain what that means. So I brought up the question of what a database query is going to do before it actually executes, and I kind of gave a little bit of that away, that you already have query planners and existing relational databases that do a good job at this. So this is a program, dbforge, and I'm just looking at a Oracle query over here, and you can see me basically walking down, and you can see what the query planner sees. It sees loops, it sees you trying to extract information, interesting metadata on the other side. And it's able to do this just from formally parsing the query itself. It's not actually executing the query on the other side, it's just examining what the query is going to do. And this is from the MySQL dashboard. So we typically see this stuff for performance, where we want to figure out what's our fastest queries, what are our slowest queries. But this tool is actually really powerful under the hood, because it's breaking apart a database query into its essence. It's figuring out what statements, what fields, what operands, what functions, and it's able to understand exactly everything in a database query, again, before the query goes back to execute in a target database engine. So we think it's actually really valuable, and there's a whole community of folks that think it's valuable not only for defense, but also for offense. And I'll be talking on behalf of the defensive side, but throughout this talk, you'll hear me probably mention a couple of interesting research projects around offense, because there's some really novel tools that are coming around, specifically with respect to taking a formal grammar and creating novel attack payloads based on the grammar itself. So terminology, you'll hear me talking a little bit about this stuff. So there's things like formal grammars, tokenizers, scanners, lexers, parsers, lexical analysis, syntactic analysis. There is a lot of research that goes into each one of these terms. And today what we're going to be focusing on specifically is around the ones that you see here minus lexical and syntactic analysis. Instead, what we're going to be doing is a demo that shows you lexical and syntactic analysis. It's much easier to show by an example rather than explaining verbally. It's easier that way. So the high-level gist of LANGSEC is you want to read a piece of input. Let's take a database query, for example, and yield a series of tokens. So when you see something like select star from users, select is a token, star is a token, from is a token, users, that's a token, right? So we yield a series of tokens, and then we want to prove via a parser that it's valid. And so is select star from users a valid statement? And it is in this case, because it adheres to the grammar that's specified for whatever target database engine that you're going to be shooting that query off to. But you can also do some interesting things after you have that parse tree, because you can manipulate it, you can transform it, you can examine it. If you see something bad or something you don't want to see in there, you could just remove it or rebuild the parse tree altogether. So this is kind of a very simple and very crude overview of it. And it starts with lexical analysis. And we're looking for things like letters, numbers, punctuation. And if you see the terms I space have, H space A, B, E, F, L, A, T. That's what lexical analysis does. It iterates over letters, numbers, these punctuation characters. And then it goes into syntactic analysis, where it puts it all together, right? So you now have the sentence, I have a flat. So a sentence that's full of these different tokens. But then you can do things like code generation. So let's say I wanted to build a system that was around adding a term to this, manipulating this in some way. And I had the context. Like you have the context that this is a database query going to a SQL Server database engine. Let's say you have the context that this is a sentence that is about automobiles, driving, or transportation. Well, at that point, you can inject in anything you want. For instance, in this case, we inject a noun. So we take tire, and as part of our transformation process, we can put that in there. If I wanted to be reductive, I could remove it. I could remove any article if I wanted to from this. And that's what you get when you actually use a formal grammar. You use a lexer and a parser to try and look at this. So I mentioned scanning. So there's various approaches on the scanning side that you can use. It starts at a very high level, basically a finite state machine. So you build a machine that's ultimately going to loop through your payload character by character or rune by rune, runes being Unicode byte sequences, whether it's UTF-8 or UTF-16. There's lots and lots of fun hacks and lots of fun pain if you decide not to go rune by rune in this day and age, and I'm sure you guys all know what those probably are with respect to overflows and fun injections that exist today. After you loop through, you can assign a value to each one of these tokens. So basically, you can say that, let's say we're parsing HTML. When I'm iterating over the 8 tag, you can specify this is in fact a tag, or select star from users. From is a reserved word. Select is a statement type. And you can attach values to each one of the tokens that you're parsing. And the interesting thing about scanners, there's lots of implementations today. There's some scanners that allow you to go n number of tokens out, and some that allow you to go n number of tokens back. All depends on the kind of implementation that exists today. Lots of generators. So I just named a couple of them on this list. I was at the Riot event last night, and the security team over there is using a tool called Antler. Antler is an interesting project. It allows you to generate analyzers on the lexical side as well as on the parser side. There's other tools like Java CC, Lex, Ragel. So lots of technologies that are available. I only just put on this list the top ones that I could just think of off the top of my head, but there's a lot of them that exist today. Now you can do this by hand, right? You could, if you wanted to, you could Lex by hand, but you really need to take time to write tests. And you should also take into account the size of your language. So it's one thing to hand roll Lexer for a calculator, because it's a relatively bounded set of operations and set of terms that are going into the language, but it's another thing altogether to try and do this for something like SQL. Whether you're parsing the SQL 2003 specification or the 99 specification, very large language, a lot of density, a lot of permutation, and you have to be able to keep track of all that. So you really need to understand your language density before you go into it. Parsing is a little bit different. So now that we've got our tokens, ideally in a token stream, we can produce this really interesting data structure, and we can yield a parse tree on the other side. So we can figure out the relationships between nodes. A good example in the case of HTML, what's an opening tag and what's a closing tag. You know that something is open that isn't closed, maybe you could close it. Or if you see something that's closed that isn't open, maybe you could remove it. So again, going back to the parse tree and manipulating that any way you want. And there's different techniques for parsing. There's top-down, there's bottom-up. Top-down using techniques like recursive descent, where you start at the highest node. You can see that on the left-hand side, where you start at the highest node, and you label everything on the way back down, and you do this recursively, top-down, left to right. And then there's the bottom-up approach. And the bottom-up approach is exactly the inverse of the top-down approach. So you label everything from the bottom, and everything at the top gets a higher value. And depending on which one you implement on the parser side, you can bring different kinds of algorithms. There's certain advantages of using one versus the other, depending on the algorithm that you bring to the table, and what you value most, and what you're trying to accomplish. There's lots of parser generators. So I mentioned the Lexers. There's lots on the parser side. So you've got tools like Antler again. And so Antler actually does the pair of Lexers and parsers. There's tools like Bison, Lemon, and Yak. And again, there's a lot of code generation that you can get done in just about any language you can think of today. There's a relatively novel parser generator that's coming out of the LANGSEC workshop called Hammer. I invite a lot of people to take a look at that. It's still relatively young, but a lot of interesting implementations, and I know it supports C#, Java, and we maintain the Go bindings for that. But it's really interesting tech. So let's skip ahead. So you can also do this by hand on the parser side, but very similar to what you saw before, you really want to understand your use case. And especially if you're starting to hand roll your lexers and your parsers, you want to make sure you keep that stuff in sync. Let's say your language changes. You now need to lex completely differently. You now need to parse completely differently. Or let's say you want to do something more novel inside of the parser while you're iterating over a parse tree. Is your lexer even giving you that information to do that manipulation? And oftentimes we sometimes see folks that are trying to do things by hand, not necessarily keeping in sync. So if you decide that you want to do a hand-rolled operation, and I'll actually walk you through a hand-rolled operation very soon, you need to fully specify the language, you need to understand the domain itself, and also what are you trying to accomplish after you do this. Just because you have the ability to parse a language doesn't mean anything unless you know your exact use case. So I spent a lot of time going through the background. I guess it's show and tell time. I put together a hand-rolled HTML lexer and parser. I saw a lot of implementations that were developed in Java today that were hand-rolled, relying on things like regular expressions to try and do the pivots. So basically it had a very basic regular expression to look for something like HTML tags and was trying to use that as a guidepost for how to parse HTML content. The other bummer of a lot of tools today is they rely on XML parsers under the hood to parse something like HTML. Problem is, a lot of people don't write HTML like XML. And something that you have open doesn't necessarily have to be closed. And it ends up blowing up a lot of tokenizers and parsers that I've used in the past. So I ended up taking and going through the W3C specification and putting together a very simple implementation that is able to parse HTML tags, attributes, protocols, and understands the relationship between them, including opening tags and closing tags. And as I mentioned before, we'll throw all this stuff up online. We'll end up using processing to visualize all this, so I wanted to show you guys what you can do with a parse tree. Not only just from a security side, but also a different way you can actually view it. And you'll see that in the 3D data viz. And then I'll run you through some benchmarks that we ran using a tool called JMH. Since all of this stuff is implemented in Java, we ended up using JMH from the OpenJDK project that allowed us to run a lot of throughput tests. JMH, for those that don't know, is really powerful and really interesting. It's actually really light to add into your existing code base. So if you already have an existing Java project, I definitely suggest you add this in. But what I ended up doing for this benchmark was taking a series of regular expressions. So again, the top 50 regular expressions from the MS-HTML DLL that Microsoft ships with Internet Explorer to the mod security rules and diffed them, made sure I was only taking the most unique and interesting ones, and actually ended up removing a lot of the cheesy ones. So the stuff that was admittedly really bad regular expressions like open bracket, dot star, close bracket, that would take a lot of time to compute. I ended up throwing that stuff out. And I ran it across different payload sizes. So whether it was 70 bytes to more than a megabyte of payloads, and the payloads I generated were from the Ipsum generator that we fuzzed with arbitrary HTML. So malicious content. We were coming up with a code name for this. I think we're calling it Alice's Script Adventures in Wonderland. So what we ended up doing was running the benchmarks all on this laptop. It's not great hardware. It's this MacBook Air from 2 years ago. The regexes, as I mentioned, are from IE and the OWASP wiki. And also important to note, the LANGSEC implementation in this case, you'll see my tokenizer and parser, is relatively naive. It's single-threaded. If you wanted to, you could implement a multi-threaded approach for tokenizing and parsing, especially since it is linear. There's opportunities to cut your payload in half and fan out the work if you really wanted to. But I ended up going with a very naive single-threaded implementation. So I'm going to head over to Sublime. So can everyone see this?
It's pretty hard to read.
Yeah.
It's the colors.
It's the colors.
Yeah, it's not the side.
Colors.
Just try the white. Color white will.
Solarize the light.
There we go.
Awesome. Got it. Okay. So let me bring this back over here. So I ended up putting together an HTML parser, and I ended up designing some very simple primitives in the parser. Very simple functions that you end up using and relying on a lot when you're building a parser. So for instance, end of file, peak. End of file lets you know when you're at the end of the file or end of the payload that you're trying to process. peek goes and tries to look at the current character but doesn't quote unquote consume it. Consume is what you see over here. It actually calls peek but advances the cursor. So when you see something like hello, you're at H, you consume, you now eat E, and you can peek, and then you would see L as the subsequent thing. So simple things that actually go a very long way when you're building one of these. Something like consuming white space. Sometimes you just need to eat through all the white space because until you get to the next significant character, that white space may not be relevant. Again, it depends on if you're in a tag node or in an attribute value or if it's just a text node. It means something totally different. But the heart of this, I'll just pull this out a little here, is in this parse method. So what this parse method is it initializes an array list of nodes, and it's looped, and it goes all the way through until we've reached the end of the file or the end of the payload. And what we end up doing is we start reading as much as we possibly can and switching between different states. So we start in the text state, but if we identify that there's a potential tag, we go into a tag state. So it's a very simple, from a very high level, very simple algorithm where we mark things as opening, closed. We're just starting to consume these tags and trying to put them all into this array list. And the idea is, as we see things, whether it's a text node or a tag node, we just want to add it to the array list. And we can follow it all the way down, and that's it. Where we just go in and we add the node, and eventually we return all the nodes. And parsing a node, for instance, if you see something like is a opening ankle rune, so a less than sign, triggers the parse tag state. And something like the parse tag state is pretty simple. You consume the character, which you know is going to be the opening ankle tag, and you know you're not at the end of the file. But if you are at the end of the file, then there's some really interesting things that you need to do, like text encoding, because you don't want to have a stray opening tag at the end of your payload. You may want to do something interesting with that. You may want to go back and find if it's, or determine if it's an opening tag or a closing tag, depending on the value that you're processing. So if it's a /, you know you're in a closing tag, versus if it's an actual literal, let's say an A through Z, you're in an opening tag. So again, I just followed the W3C specification, went back in and designed it based on that specification itself. And overall, it's a very, very tiny parser, so about 330 lines. And this actually parses, it passed the initial WC3 tests for parsing tags, attributes, protocols. So very, very simple, doesn't require regular expressions or anything like that. But what I'll show you now is the actual regular expressions that I was able to pull. So here is an example, or here are the 50 that I was able to pull in. So this is partly from the IE dataset, partly from the mod security section of the OWASP wiki, and I think some stuff from Stack Overflow as well. And you can see the insanity and the craziness of the regular expressions as you go all the way down. And what's absolutely crazy to us is people have to maintain this. Right? This isn't just something you get and you just plug it in and then you walk away. You have to maintain this list, you have to curate this list. And what we typically found is this stuff, as you continue to add more and more regular expressions into the run, ends up slowing things down. Because this stuff eats CPU. Every time you run this regular expression, you're running the regex over and over again on a piece of input. So let's say you have a piece of input, and you're running a regular expression, you got to run that regex over and over and over again, or multiple regexes on that input, versus a LANGSEC approach, you can iterate once through, build a full parse tree, and then manipulate the parse tree any way you want. So you don't have a lot of that overhead that a regex does, even if they're compiled regular expressions, as you can see over here. And so we use JMH. JMH is able to give you some pretty nice benchmarks, pretty nice data. And so what we ended up finding was those regular expressions, and we added 50, 100, 500 regular expressions. And remember I told you the MySpace use case. I thought we were insane by having 1,000 regular expressions. It turns out that a lot of folks, whether they're in IT services or not, in their web application firewalls today, they actually have way more than that in those firewalls that are looking at inputs that are coming into their environment. It requires a lot of tuning and a lot of investment. So the regular expressions are fascinating to us. We ended up running the JMH suite, and the JMH suite, you can see the tests payloads on the other side going from 10 to 10,000. And this is the number of operations a second on the other side. So you can see with 50 on a set of 10, so where you only have 10 words in the data set, you've got 11,000 operations a second. It's pretty good, right? 11,000 on a crappy MacBook Air is pretty decent. And all the way down you see a corner where you've got 500 regular expressions on a really large data set of 10,000, 1 second, or only 1.3 operations. Now you compare with the LANGSEC implementation, right? So obviously the payload size is increasing. You would expect it to follow the linear pattern that a series of regular expressions would be doing. Ultimately, you're doing and implementing tokenizers and parsers that are inherently available inside of a regular expression today. And you can see the delta on the other side. So the same test, this parser on a crappy MacBook Air, where you have 11,000 with regular expressions, yields 363,000 operations with LANGSEC. I'll get to the...
Just real quick clarification.
Yeah.
So you ran this parser against HTML?
Yes.
Aren't these regexes from security, aren't they designed for HTTP requests?
I only pulled the HTML ones.
Okay.
The ones that were pulling HTML. Yeah, so as you saw in the examples, I only pulled the ones that had or dealing with actual HTML content on the other side. Cool. So you can see the delta in operations per second, basically 30x faster on the other side. What I want to do is actually show you the parser itself in action, or what you can do when you have it. So hopefully the demo gods are on our side. I ended up putting this together in processing. I think it's a little bit easier to see this. And hopefully you can see the data viz. Unfortunately, it's on a black background. And if you have problems seeing the data viz here, come over after the talk, and I can huddle around, or we can huddle around the laptop and we can see it. But processing is an interesting visualization framework. It basically requires you to flex whatever OpenGL muscles you may remember somewhere in your cortex. And the thing about it that I really like is it allows you to take whatever you've already written in Java and bring it into this environment and use it where you like. So what I did was I compiled that jar file that you just saw, part of that code base. I dropped it in, and I was able to take advantage of it. And so what we're going to be doing is evaluating something pretty interesting, which is various DOMs from various pages. So I ended up taking the AppSec webpage, the Brevity webpage, MIT, DuckDuckGo, and a couple of others. And what I wanted to see was how fast we could process it, and then what we could see, assuming that you wanted to bring a whitelist, or if you wanted to allow certain nodes to be available in the DOM itself. So let's go back in. Let's run this. So again, I apologize if it's hard to see from over there. Let me see if I can increase the size. Let's increase that to 5. Yeah, if I change the background color though, unfortunately you won't see the other stuff, which is like the lines and the representation between them. I could try. Let's see what happens if I do that. This is, I think this will be the background color, but okay, a little bit better?
Yeah.
Cool. So this is processing, and what I was able to do was parse a DOM, and using the same parser that I was using before. And so you can't necessarily see these labels, and I can't see these labels either. But this is the output on the other side. So this is just a local test. I brought it over here. We can take a look at the AppSec webpage. And so with the AppSec webpage, different colors for different things. So I was saying that I was only going to whitelist certain nodes. Again, once you have a parse tree, you can bring any whitelist you want to this table. You can't see the tag names, unfortunately, because they were implemented in a different color, or the curves between them. But this is just showing you the text nodes that are in the DOM itself versus the relationships. I know you can barely see it. You probably see it slowing down a little bit, but there are tag names, I swear. So things like that are all inside this data visualization. And we think this is pretty interesting because LANGSEC doesn't just have to stop at security. You can actually do some really interesting things with the data on the other side. So we'll have this whole visualization set up. as part of the code example that's going to be available, it will be a GitHub gist, because processing actually runs in the browser via Java applets. What you'll be able to do is plug in any website you want and generate anything like this. And we think it's pretty impactful to go down this path. We were thinking about also, for this talk, was thinking about figuring out how we could parse and visualize SQL queries. But ultimately, SQL is a little bit different of a beast now because it actually fits the idea of what you see with an HTML page where you have opening tags and closing tags, you have relationships between those tags, things like that. So, like I said, all this will be available, and if you guys want to see it in black and see all the different controls of how you can augment this, feel free to come on after the talk, and I think show it to you on my laptop. But it's pretty fun stuff. So I know we're approaching the end over here. And what I wanted to do was starting to wrap some stuff up with a few slides. So I think having access to both the payloads and the correct context makes a really big difference. And I think that's where LANGSEC has a really important opportunity. Because if you're actually able to look at content the same way that a web browser is, or if you're able to look at database queries the same way that a database engine is, I think you have a much more advantageous perspective compared to the alternative solutions, which is something like regular expressions. When you don't have much control, you basically get what you get and you kind of have to live with the result. Versus when you take a LANGSEC-oriented approach, you can inject yourself anywhere in the process, whether it's at the tokenizer, whether it's at the parser, whether you want to manipulate things or change things around, you can inject all sorts of security anywhere you want. So I mentioned a couple of things. You guys saw the demo on the defensive side. On the offensive side, I'm seeing some incredible research with people doing some fun stuff with LANGSEC, where they're actually going to load a grammar. So I've seen this done where someone, it's not a named project yet, but they load in a MySQL project, a MySQL grammar. So they take the grammar from MySQL, and then they're able to craft a bunch of attack payloads just to prove that those payloads themselves can't make it through onto the other side. So they end up parsing regular database queries inside their application. They find the gaps, or they find where interpolation could happen inside the application, and then they rerun it through the grammar, and they generate new attack payloads that they can try and interpolate and create SQL injection attacks. That's kind of an interesting use case that we're seeing. I'm also seeing a lot more advanced use cases for people trying to create things like cross-site scripting attacks, where they're not just taking the cheesiness of script alert 1, they're actually trying to do some fun, dumb hackery, whether it's injecting tags into other tags, doing interesting kinds of segmentation, interesting kinds of interpolation to create that. And I believe that LANGSEC is a really interesting and powerful thing. It's just, at this point right now, if you think about it, it's still a relatively small community. And there's not that many people that know about LANGSEC. It's growing, but a lot of people don't know about it because it's just a different way to think about the problem. We've been trained to think about regular expressions and using regular expressions for a very, very long time. Regular expressions are easy, right? We all conceptualize exactly what they're trying to do and what they're generally trying to accomplish. But when you compare it to the performance metrics of something like LANGSEC approach, the gap really, really shows itself. It's really clear as to the pros and cons of each one of these things. So you have the ease of use on one side of something like regular expressions versus actually being able to parse content, parse database queries on the other side. And fortunately for us, the tool set is getting a lot better. Whether you're using lexer generators, parser generators, the tool set is improving. It is getting better. And we're finding that because of the improvement of these tools, people are doing a great job at furthering LANGSEC. There's a yearly IEEE event that happens, and I highly recommend for those that are interested in LANGSEC, you should definitely go to this event. It's in the Bay Area, and it's a lot of nerds just sitting down and actually talking and implementing stuff. There's a lot of great research that comes out of the workshop itself. So it's not just a workshop to have a workshop, it's a workshop that's actually practical. One of the questions that we have to ask ourselves, though, is how can we make LANGSEC more approachable and open enough for other people to jump in? So I mentioned the tool side of things, but what if we could go a step further? And hopefully this year, I know we will be trying to advance LANGSEC research. We want to try and open up and make data sets freely available. Because if you think about it, being able to build a LANGSEC implementation is only as good as the language itself. So let's say you want to parse MySQL. how can you prove that your MySQL tokenizer and parser are actually good? It's really, really hard to unless you have test MySQL queries. So one of the things I would like to see the community do a better job at is releasing data sets, whether it's anonymized data sets and hopefully anonymized data sets for things like MySQL, SQL Server, Oracle. And that way, once we have these tests together, or at least test data sets, we can start to build expected results on the other side. And maybe at some point, and I know this is a pipe dream, we can start to get to a place where we have a Netflix prize-like contest where people can bring LANGSEC implementations or different implementations to the table, where they're taking a tokenizer and maybe they're optimizing a tokenizer in some way specifically around a data set, or maybe augmenting a different kind of parser for a different kind of data set or different kind of language on the other side. So, key messages, I want to leave some time open for some high-level questions. It's a very different methodology. We think it pairs nicely with application security, especially given the kinds of things that as AppSec professionals we have to deal with, whether it's SQL injection from the application to a database engine, command injection from the application to the operating system. Again, this is all using a language that has a defined and known grammar. What if we just understood those payloads the same way that they would actually execute? It's also a lot faster than something like regular expressions. It's just a big question now, how can we evangelize it as a group? And I'm genuinely excited for the LANGSEC community to keep going. So thank you guys. I really appreciate you guys being here and allowing me to show you some demos. Like I said, if you guys want to huddle around at the end of this thing, you absolutely can, and I can show you the data visualization, data viz in depth, and it's pretty fun stuff. Thank you.
Like 3 talks in and there's been no Q&A. I'm really kind of surprised. When you come to my talk, I will try to have Q&A.
I think you got 10 minutes.
Yeah, so one bigger sort of philosophical question. Maybe it's very short, I don't know. It seems to me, looking at this, that you'd have to write a parser, a lexer and a parser, for each language, each expression, which seems to, I think that's probably why people have shied away with it. It's not entirely new because I remember years ago, and I'm sorry I don't remember the product, but there was a pipeline security product in like 2003 that was doing this kind of stuff. But then our world was much smaller.
Mm-hmm.
We didn't have 15 web languages we had to cover. So am I getting it right? You have to really build one of these for
Yeah,
each?
and it's really about, so in our case, we think about it in terms of, let's say SQL injection, so let's parse the SQL queries, or command injection, let's build a tokenizer and parser around dash, or around command.
Sure, okay.
And you're absolutely right. And
Yeah.
so I think there's a couple of ways this is going to get better. One is you get people that write really good implementations that get open sourced and that get pulled into known libraries. So whether it's contributing it back to OWASP or whether they get coupled with existing frameworks or technologies and get pulled back in, that's probably going to be the way forward for LANGSEC to probably hit a lot.
So why wouldn't you be able to hook or utilize the parser, the existing parsers, their strengths? You also inherit their weaknesses, but it would seem to me you've got parsers, lexers and parsers for each one of these languages already. You know, I'm just trying to leap along, so maybe you could comment on that.
Totally. And I'm glad you asked. So we wanted to build, I'll give you an anecdote, and that this will explain it. We wanted to build a parser around SQL queries, and we were using a tool called Antler. And unfortunately for us, the open source grammar that existed in MySQL for Antler just wasn't good enough. And when I say good enough, we were lobbing very trivial database queries over to it, and it was just failing on it. And we just found ourselves in a situation where we were playing with a lot of open source grammars, they just weren't maintained very well. Because I think a lot of people were writing these grammars not from a security perspective, but maybe as a pet project. Or maybe they wanted to transpile.
Their PhD thesis.
That's a really good one. And the LANGSEC community is certainly full of that. Because again, you're taking something that's relatively academic in nature, right? Tokenizers, parsers, et cetera, and trying to make it more accessible. And I think it's been held by a lot of.
So there's a gap there somewhere, if I understand what you're saying.
Yeah, I think.
Between what's out there and what we need for security.
I think there's a fairly big chunk in this where for the likes of natural language parsing, they started trying to understand sentences fully and then backed off from that and said, can we understand noun phrases and verb phrases, and simplified it. when they moved to that step, they got to a point where you could sort of go, actually, we can infer the structure of particular languages. And then there's a movement that kind of then started stepping further forward in terms of machine translation. And one of the axioms on machine translation was moving from Latin languages to Asian languages. If you're just looking at characters, it's quite hard, but the human vocal box can only make so many sounds. And actually from translating it into that audio realm, it was a lot easier to go through. So I think there's a whole bunch of research around making automated first steps which you can improve. And I think there's an awful lot that you could infer. And then when you look at the Googles of this world who solved this machine translation basically by having lots of answer phone messages which were transcripted for them, and it ended up just being a big bag of stats that solved the problem.
Just coming specifically to the HTML parser, we have some of the best HTML parsers are open source, right? Did you consider using any of those? Or they just not in the language that you're familiar with?
No, there are some really good ones. So it just wasn't the use case that I needed. So a good example of this is I dug into, I think there was an OWASP project. I don't think it's anti-SAMI, but I think it's one of them that relies on a regular expression inside, I believe, to do a pivot. So I think there's regex and all kinds of stuff. But yeah, there are some well-known ones. JSoup is another one that keeps me.
I'm talking about the browsers.
Oh,
like
yeah.
WebKit, Blink.
Right, and
right?
yeah, and you can certainly pull that stuff in. I think it's just at a lower level where you have to write wrappers around it because no one's writing a parser for a browser in Python or in Java. Otherwise, it would be really, really slow, and then you get much crappier results on a MacBook Air like mine.
Have you heard of Dexter.js? Because I think that's what they're doing.
Oh, cool.
And if you talk to me later, I can introduce you up. It's an academic project, but they managed to parse, and I think this is what they're doing. I know the guy, met him a couple times, but it's from Singapore. It's a he's a professor and he's got a bunch of grad students. But they've managed to parse JavaScript only for cross-site scripting at 100%.
That's awesome.
And so that's kind of in the same realm, I think.
So
I could hook you up.
Yeah, no, I would appreciate that. That'd be awesome. So I can spend maybe like a minute talking about DOM.XSS because that's something that's totally and utterly different than this. Oh, thank you for the contribution.
Yeah.
So DOM.XSS is a fun one. Years ago when I was at MySpace, we had a project in conjunction with Google called Kaha. Not many people remember Kaha. And the idea of Kaha was how can you make JavaScript safe? And they created a process, Kaha means box, translates to box in English. And the idea was if you own the language and you own the runtime, that's the only way you're going to make JavaScript safe. And so the idea was they would cajole JavaScript. And so they would take the jQuery libraries, they would run it through Kaha, and you would get Kaha safe JavaScript on the other side. And it was an interesting project because you also have to own the runtime because you can do all the static or dynamic analysis you want of JavaScript. You can hide any behavior you want in JavaScript using all sorts of mechanisms. And ultimately, for something like DOM.XSS, you actually not only need to do some sort of static analysis, maybe as a first pass, but ideally you need to throw this thing in an actual web browser and see what happens on the other side. I don't think anyone would suggest that a LANGSEC-oriented approach is the only approach or even a valid approach for looking at something like DOM.XSS. So to the point that gentleman brought up, tools like Dexter, Phantom, other tools around browser automation really is valuable. I heard a thing in passing from some gentleman here today saying that the way eBay looks for DOM.XSS is by automating various browsers, for instance. And I think that's really interesting because ultimately they can take whatever signature-based approach for looking at the stuff. You actually need to watch this and actually execute.
So this seems like it's kind of an emerging thing, and it doesn't seem like it's almost to use the term production ready. But are you guys leveraging LANGSEC and Privy at all? Because this is what you're doing with your products. Is this something that you can implement in the real world, or?
Yeah, and so the question the gentleman brought up is this production ready? We found that a lot of the grammars that existed today are not production ready. And to get it production ready, we need real data sets in a real world environment. And I'll speak, let's say, the SQL injection stuff that we do. We live in an application which targets database queries the same way that those targets are. So we found that we needed to really build grammars from the ground up. And fortunately for us, there are things like EDNF diagrams for how a query should be constructed for tools like, or products like DB2. But then you get to a product like MySQL or SQL Server where there is no formal grammar. You actually end up having to look at the code to see what's actually going on in each one of these products. So it's really hard to extract that stuff out, especially when it's domain logic that's just constantly changing over time. And so if you want to make it production ready, which we did, you have to invest thousands and thousands of hours to do that. And what I hope is that, and you'll see stuff from us that we'll push back into the community this year, but our hope is that there are silos of really smart people doing interesting things with LANGSEC. Hopefully some of that work can trickle back up, because I think it's really novel stuff, and I think it can go a long way. It just needs to be packaged a little differently, or maybe combined with existing libraries and techniques that are out there.
There's one thing that seems interesting about this is it seems like in order to produce something that's going to be viable and that's going to have a low false positive rate, it's going to take a huge amount of effort per language. So it's something that'll be interesting to see the uptake from the community. It's something that people really, rally around, or if it's something people find is too much investment.
I really hope that we can try and get an ethics project off the ground. Hey, thank you guys, everyone, for coming.